Okay, the big thing about cellular adaptations is like, okay, angiogenesis. So it's basically just the creation of new blood vessels. There are angiogenic factors and angiogenic inhibitors because everything in the body has, like, this does this and it has a counter thing to make sure it doesn't go crazy. I didn't really see this come up in the adaptable quizzes, um, but it basically just regulates angiogenesis. So, like, kind of what I sort of am kind of understanding is, like, when you're creating new blood vessels, it's like proteins. So that is all that's going to require transcription factors, RNA, mRNA, transcription, creation. So basically, as a transcription factor, this hypoxia inducible factor 1 alpha, um, it's basically like, are we going to actually create this protein or not? Are we going to do this or not? So that's how it kind of, to me, how I interpret that it regulates angiogenesis. Inactivation of tumor suppressor genes leads to increased expression. Oh. That's a little, I have to kind of sit there and wrap my head around that one. Oh, this one's super important. Okay, these guys are crazy. This is really interesting. These are enzymes that literally degrade the surrounding tissue, um, and then basically, like, the tumor starts, like, laying down its own vessels using angiogenic factors. So these guys come in, they're like, we're gonna, like, rip out the foundation here, and we're gonna make this a nice little place for some blood vessels to be laid down. That's, oh my gosh, I forgot about that. Okay, vasculogenic mimicry. This is like the tumor cell is basically creating a structure to trick red blood cells to coming and giving them a blood supply. That's, oh my God, that's so crazy. I forgot about all this. Um, Successful cancer cell divides rapidly with a consequent requirement for the building blocks. That's crazy. Oh, yes. Tumor cells, cancer cells, they prefer anaerobic glycolysis. So they prefer creating energy through an absence of oxygen. Um, so that's definitely a little bit wild. Reprogram metabolism is a hallmark of cancer. Oh, low battery mode. That sucks. Modes of nutrient use of glycolysis. Okay. All right, let's keep going. The Warburg effect came up quite a bit. So this is something to remember. They basically, cancer cells prefer to produce ATP through glycolysis. The Warburg effect is the use of glycolysis under normal oxygen conditions, hence the name aerobic glycolysis. Wait, hold on. I think I got confused. Oh, okay. There's two different ways we make ATP. So this goes back to oxidative phosphorylation, in which the mitochondria yields a result of 36 ATP, and it goes through, like, the electron transport chain, blah, blah, blah. So glycolysis is basically like the breakdown of sugar to create ATP. Usually it's anaerobic. So, like, that it can basically go into a fermentation cycle, which is an anaerobic thing that produces lactic gas. Glycolysis is also basically the backup energy generator when oxidative phosphorylation fails. So they're basically saying the Warburg effect, cancer cells are, even if there's plenty of oxygen, they still prefer to use glycolysis. So they still prefer to basically have like sugar breakdown in order to make oxygen or energy. Um, Okay, so glycolysis allows lactate and other products of glycolysis to be used for more efficient production of lipids, nucleosides, amino acids, and other molecular building blocks needed for rapid cell growth. So they're basically just saying, like, the reason why cancer cells use glycolysis is because it allows them to basically create building blocks for building blood vessels and for destroying other cells. Like it literally is like it helps them rapidly grow because you're using sugar. like um okay, let's keep going. The reverse Warburg effect, just the big thing is to remember the Warburg effect, which is aerobic glycolysis, and that is specifically like a cancer associated cell cycle thing. Excuse me. We apoptosis. So cancer cells can basically resist apoptosis. Um, okay, I just want to like try to keep going because I know my phone is like tumor promoting inflammation. So basically, like tumors can manipulate the inflammatory process in their local tumor microenvironment to benefit. So basically, they use inflammation to their advantage. So like chronic inflammation is highly associated with cancer. That includes solar irradiation, asbestos exposure, like mesothelioma. So, like we were talking about before, like in Barrett's esophagus, there's so much inflammation and cellular change from the carcinogens that you develop cancer. That's basically all they're saying. Is inflammation is like the perfect breeding ground for cancer. That's the big idea there. All this is talking about H. pylori. So basically, H. pylori is that bacterial infection that can basically destroy like your stomach and your intestines. So you have mucosal associated lymphatic tissue, basically like in your intestines. And they like as you're processing food, like they'll try to like pull out pathogens and stuff, but you can develop lymphomas if you have like a chronic bacterial infection from H. pylori. So that's kind of something to keep in mind. This came up a couple times in the quizzes, the adaptive quizzes. Tumor-associated macrophage. Tumors commonly produce cytokines and chemokines that are chemotoxic factors. Okay, so what's the big point? I really did skim all of this. Macrophage infiltration and progression with a worse prognosis. From the blood, come to the tumor, they mature into macrophages. Ugh, acute inflammatory responsible for sugar infection, during healing. Produce anti-inflammatory. Okay, TMs appear to be oh my god, that was too long of a description. They're basically saying like this tumor-associated macrophage is basically the same thing as just a regular macrophage. But they have diminished cytotoxic response and release that block T. Oh, this is a big thing. Tumor-associated macrophages block T cytotoxic cell and natural killer cell functions. So those two, the T cytotoxic and natural killer, they usually are able to kill cancer cells, but these TAMs, they prevent them from basically being able to do that. So then you can basically just have cancer proliferation. This came up, they synthesize the ECM that surrounds and permeates the tumor. So they basically, cancer-associated fibroblasts basically help to just continue to create the environment for the tumor. That's basically what they're saying. Oh my God, viruses and cancer. You have, okay, so Epstein-Barr virus, which is like, when you get mono, can lead to Kaposi sarcoma. So this was all these were in the quizzes. So this is definitely important. Like Epstein-Barr virus leads to cancer. HPV leads to cancer. hepatitis B and C viruses and MRSA are associated with about 12 to. So these things are all associated with cancer, and I'm sure it goes through all of this. So I would say maybe like the big thing here would just be like if you can identify like Kaposi's sarcoma, Kaposi. I think you can get that like if you have HIV. Are unaware of their infection. Oh my God, just get to the point. Hepatocellular carcinoma, HPV. Okay. Oh my God, get to the point. Get to the point. I didn't see any of these really. All this stuff I didn't really read, and I haven't seen it like come up on the quizzes. Tumor infiltrating lymphocytes. Like, so this would be something that I would be like, okay, I'm gonna like tumor infiltrating lymphocytes. Like, this would be something like I would look up and I would just be like, what's going on? What the hell are these things? So honestly, like, that's what I do. When I start to get exhausted by the chapter, I just look for like bolded or italicized words, and then I just like look it up because I'm like, I don't know what this is, and I don't want to read this book anymore. In tumors, cancer cells manipulate Treg cells to prevent anti-tumor immune responses. Oh, so that's all it is. There are immune cells found within tumors. That's the big thing. Like, okay, there you go. Metastasis is like how it spreads. So chromosomal instability is a big determinant of it. So a big thing is when cells lose their cell-cell adhesion. So they basically detach from each other and from their environment, and that they can invade, resist stress, and disseminate, meaning they can basically just go wherever they want in the body and just proliferate. This is so wordy. I am like so upset about this giant paragraph. It makes me angry. I don't want to read it. Ugh, I don't want to read any of this. Hypoxia-inducible factors. Look, there it is again. Oh my God. Is this? This is insane. Okay, this came up. Plasticity is the ability of cancer cells to dynamically switch between a differentiated state and undifferentiated cancer stem-like state. Okay, that came up. So plasticity is basically just like cancer cells can be cancer cells, or they can go back to like looking like a normal cell. I did not look at any treatments because, oh, this came up. Paraneoplastic syndromes are rare disorders with complex clinical manifestations that are triggered by cancer but are not caused by direct local effects of tumor mass. So basically, paraneoplastic syndromes, they create these tumors don't metastasize, but they're evil or nasty because they create autoantibodies, cytokines, hormones, or peptides. So that, think of like an autoimmune disorders when like the inflammatory system's basically just attacking itself. That's essentially what happens. Oh my God. Oh, hey, look, Cushing syndrome. Jesus Christ. This is horrible. Oh, cachexia came up. So it's basically like loss of muscle without loss of fat mass. So like this can happen like anorexia, AIDS, chronic obstructive pulmonary disease. So this was definitely cancer. Cachexia is characterized by systemic inflammation, negative protein and energy balance, and loss of lean body mass with or without wasting of adipose tissue. But that definitely came up in, so it's basically like the weight loss, but without like losing fat. I this is just, oh my God, this chapter is too long. Okay, this is going to be a whole separate thing. I don't think I'm going to do this one right now.